Thank you everyone for joining us today for this webinar on how to build a modern data stack. My name is Parag and I work as a product marketing manager at Hevo. I will be your host and moderator for this webinar. And let me introduce you to Ruben Ugarte, who works as a data strategist at Practico Analytics, and he is our guest speaker for this session. Before we start today's webinar, I would like to remind you of a few things. All attendees will be on listen-only mode. We are going to record this webinar and we'll be sending you the recording post this session. So no need to record at your end. You can type in your questions anytime during the webinar in the Q&A window available on your screen, and we will address them all one by one at the end of this session. Okay, so before we start the session, let me quickly walk you through today's agenda. First, I'll give you a brief introduction about Hevo. Then we will deep dive into our today's topic of discussion. And in the end, we will do a Q&A session. I'm sure most of you would already be knowing Hevo, but as we have a lot of new attendees, so I'll spend a minute on giving you a quick high-level overview of Hevo. So Hevo is a no-code data pipeline platform that connects and loads your data lying across multiple source systems into a single data warehouse of your choice, such as Redshift, BigQuery, Snowflake, and many others. So it provides pre-built integrations with over 100 different data sources and also supports advanced data transformations. Hevo is currently used by over 500 data enthusiasts who are working across 10 different verticals and are based in 14 different countries currently. So for more information, you can check our website www.hevodata.com. So with this introduction, I will directly jump on our today's topic. Before I hand over control to Ruben, let me give you a quick introduction about him. So Ruben is a data strategist at Practico Analytics. Practico Analytics is an analytics advisory firm that helps companies better understand and use their data. Ruben has worked with over 70 different technology companies from 5 continents and helped them achieve higher quality decisions to lower acquisition costs, saved hundreds of thousands of dollars, and reclaim waste time with their data projects. He's also a blogger, and his blog has been read by over 1 lakh readers. So that's quite amazing. All right. So let's hear Ruben. Ruben, over to you.
Perfect. Thanks, Parag. Hi, everyone. Yeah. I'm excited to be here. Let's see if I can share my screen.
Okay. Perfect.
Perfect. So today we're talking about how to build a modern data stack. Let's get my introduction and let's just jump straight into it. So this is what I want to do today. I know in the audience we have different roles, and the presentation is designed to have something of value, whether you're a data engineer, a data scientist, data analyst, maybe you're in charge of making some of these technical decisions, and maybe you're non-technical. You're trying to figure out what this means for marketing a product. So we're going to take a look here through the current state of where we are. What's the context that we're having this presentation in when it comes to data warehouses, BI, maybe just analytics in general. I want to give you some great examples of what a data stack can look like at a really high level. You know, when you look at a company like Airbnb or Gojek, which have significant resources to invest in their data stack. Talk about some of the SaaS models, the adoption of SaaS, how this is changing companies to adapt their data stacks. Then go through data stacks, and then I have a case study here from one of my clients on how their data stack was built and some of the process and principles that you can follow. So I'll go for about 25 minutes, and if there's any questions along the way, put them in the chat, and then we have a Q&A section that will cover after. So this is where, data has always been popular for the past 20, 30 years, but it's increasingly more popular. In the past maybe 5, 10 years, we've seen a big rise in more companies starting to adopt machine learning, data mining. So not just visualizing stats, building reports, but really using more advanced techniques to have some value, whether it's to do with risk or marketing operations. We're seeing tons of different applications for machine learning. Especially even in marketing sales teams using it to qualify their leads and just day-to-day things. So machine learning, AI, interchangeable terms. The terms are still also being defined on what it truly means to have AI and machine learning, but the desire for companies to go there is increasing year over year. And if you look at any survey from executives and technology companies, and even non-technology companies, data, AI, machine learning is typically one of the biggest priorities. But there's challenges. The amount of data that's available now for any given company is quite large. I work with companies of all sizes, from small startup, 20 people, to companies of a few hundred employees, and even public companies. And even at a small scale, just the amount of data is incredible. So it's a challenge on how you collect all this data from a very large amount of sources that increases, every day, every month. There's different kinds of data, diverse types of data. If you're familiar with the idea of structured data versus unstructured data, both of them are increasing, and companies need to find a way to capture it all. And of course, lots of new technologies. Probably one of the most popular things that people ask me is just tools. What tools should I use, of all kinds? And there's always new tools coming out. So trying to make choices on that can be quite difficult. And lastly, there's an interesting trend in how ETLs are being deployed. ETL historically has been about extracting data, then you transform it, you do something to it, and then you load it for analysis. But now, as technology becomes better, cheaper, we now see more companies extracting the data, which is becoming more of a challenge with more sources and more data. But then they just load it into a data warehouse, and then they'll transform it. So a little bit of a change of workflow then changes how companies approach the data. Part of this trend is seeing more and more companies move from on-prem solutions to cloud solutions. So more of a SaaS model, from companies offering SaaS models and companies wanting to work in SaaS models. The appeal of SaaS models is straightforward. Typically, the initial cost might be lower than an on-prem solution. There might be less maintenance, especially on hardware. You might be more likely or easier to find a software developer who can manage AWS than someone who knows how to manage actual servers. There's, of course, less physical space to host the data. You can scale faster, and you have access to more real-time data. So companies adopt more SaaS tools of all levels, marketing, products, sales, and that also increases the amount of data that's coming through. Some of the drawbacks of this SaaS adoption is the amount of data that we've been talking about, and those increases almost at an exponential level. I had one client that they're 20-person company, and even at that early stage, they were a mobile app. They probably had about 10 different sources of data on the marketing side, from different digital advertising, their email marketing tool, their CRM, and so on. And that's a small company. You take that and you grow that company in size and demand, and you have a lot of data from a lot of different sources. At the same time, I'm sure many people have heard, the horror stories of being having large bills from AWS and different cloud solutions. So there's still some learning to be done there for a lot of companies on how to properly manage their cloud setups. And of course, security and privacy can be a little easier to skip on the cloud side. It's so easy to deploy and get something up and running that the security portion might just be an afterthought. So data stack, and the word stack is quite popular now. You have marketing stacks and sales stacks. But data stack is simply the different tools that your company will use to capture data and then build reports and insights. And in some cases, use more advanced techniques like machine learning and AI. And the data stacks that we'll see, we're going to capture data from different sources, the structure versus unstructured data I mentioned before. You have products, whether it's mobile apps, web apps, maybe some machine generated data, from an email provider or a CRM, offline data, other sources. And I'll give you some examples of what this look like. Now, this is, let me see if I can make this a little bit smaller. So this is Gojek, a company in Asia, and they have different apps or products under their brand, like food delivery and ride-hailing. So this is their data stack, which is in the Medium article, and it's quite advanced. But if you look at the stack, fundamentally, there's some basic things here. There's the data being ingested on the far left, APIs from apps, offline data. It has to get consumed. For technical and non-technical cases, we see some data streams, for example. So they create different elements of the data to be consumed by different teams. There's, of course, data visualization. In here, you might find tools like Tableau, Domo, maybe just SQL. And then because the infrastructure is quite technical, we also need to monitor just the entire infrastructure to make sure the data is flowing properly through it. So we have a lot of different tools for doing load testing, managing the overall infrastructure, and then monitoring the data. Another example is Airbnb, a little bit more simple than the Gojek, but still fundamentally the same ideas. Where we ingest data, event logs or MySQL dumps, then it gets stored in these clusters. Airbnb in this case actually replicates the clusters for reliability. And then they have ways of making the data available here. It's actually hidden a little bit by this thing, but we have Tableau and some tools here that are more designed for data scientists to access it. So this is a data stack. A data stack like this, of course, requires quite a bit of maintenance. I think Airbnb has about maybe 30 data engineers just managing a stack like this. So I'll show you different ways the stack can be built depending on what capacity you have. So when it comes time to build data stacks, there's a few things we want to look at. We of course want to make them modern, which means the data should be accessible through any device. It should have a consistent naming convention or schema behind it. Integration is a big part of the game now. So whatever tools you have, not just in the data stack, but things that connect to the data stack, marketing tools, product tools, sales tools, having the way to integrate all of this data and make it flow from it. When we design data stacks, we're also seeing how data is moving from place A to place B, and making sure that it's able to move throughout and able to stay consistent. And it's one of the things that we're trying to build in a data stack is some kind of unified user view, right? We can take John Smith as a customer, and we can see everything John Smith has done throughout your business and product, and see the different interactions that John Smith is having, and be able to track that accurately. And of course, it doesn't matter how technical or complex or really fancy it is. At the end of the day, we need to output insights that are relevant. They're going to help marketing, going to help product, going to help operations, or whatever it may be. So we don't want to lose sight of that goal and have something that's quite advanced and quite incredible in the way data flows, but there's no way to actually get insights out of it. So let me walk you through a case study here. This is a mobile app, and they're a B2B consumer app available on iOS and Android. They also have a web app portion, so they will be a cross-platform product, which is quite common these days. And they were tracking about 150,000 users per month. And some of the challenges that they wanted to solve when we started working together to build the stack, they needed to understand user behavior across all platforms. So same thing, be able to look at a user like John Smith and see how this user is behaving on iOS, on Android, on web, and any other relevant activity. They were also getting ready to ramp up paid spending, in their case, Facebook ads and Google ads. So they needed a way to attribute this data across web and mobile. They also needed to communicate with users through email, push notifications, and in-app notifications, and ideally do that through behaviors. So send an email based on what the user has done or not done, and then build reports and dashboards for their core KPIs. So this is the process that I took them through, and the process is very similar. Even as a company grows larger, you might just have more people involved or more teams involved. There's always an element of data strategy to be done at the very beginning, and I like to focus the strategy on three fundamental elements: the people, the process, and the providers. Then we design the stack. This is where we're choosing tools. It's typically a very fun area for companies. This is where you get to go crazy and see all the available options and then come up with something that makes sense and that integrates with each other, and that's gonna have the data flow that I mentioned before. Then we have the data schema and preparation, and this is where we're designing how the data is gonna look, the naming convention, where the data might be coming from, what the data looks like, a pretty critical area when it comes to data stack design, and will determine how useful your data is by the time you're done implementing everything. Then we implement, we QA the data, relatively straightforward. And then lastly, we train. And training is the way to hand off the data, especially if you're in the technical side. The first 4 steps are probably quite straightforward for you, but the handoff between what you've done to the people who are going to be consuming the data, who might not be technical, typically gets closed by training. So data strategy, three elements: people, who's going to be using the data, how technical are they, who's going to implement it, what kind of resources do we have available for that? Is it just front-end engineers? Do we have back-end engineers? Do we have any engineers at all? And of course, who's going to maintain it? In the companies I work with, the maintenance as question is sometimes ignored, but who's actually going to keep this up to date as you release new products, as you want to add new tracking changes? Then what's going to be the process for extracting insights? So the marketing team might have a process for that, which might be different from the sales team or the product team. We also want to talk about data privacy. Some companies do not care very much about data privacy. It's not a big concern for them. And others do have to comply quite heavily with GDPR or CCPA in California. So just thinking what's going to be your data privacy policy. And then how you're going to document best practices. So as you go along, there's going to be ways in which you define KPIs, or you build reports, or even just analyze marketing campaigns. So how are you going to document those best practices? And then lastly, providers, which is just tools. And this is just about choosing the best tools for your stack, trying to match them to the technical capability of your team. So if you have a team that doesn't have a lot of data analysts in-house, for example, you probably don't want a data stack that requires SQL for everything. You might need more self-service tools. On the flip side, if you have data analysts and data scientists, you might not need self-service tools. You can just do everything through a data warehouse and SQL. And of course, budget limits what tools we can use. When we look at a bit of a stack design, we can see this is more of a marketing stack, but you can see how data is flowing here, and we can think about it from roughly 2 ideas. Data sources, where data is coming from, which can be a backend system, websites, apps, offline data, lots of sources here. Then we actually want to take all this data through a user model, and we want to unify it as much as possible. So this is what I was saying about John Smith, and being able to track what this user has done in detail, and by name and email and user ID. And then we can flow it down to some of our other tools, whether it's Google Analytics with marketing attribution, Mixpanel and Amplitude user behavior, or any of the other options here. So some of the stacks we saw before from Gojek and Airbnb are typically more on the the far left here, the capturing of the data, doing something to it to to create a user model, to clean it, to transform it, and then it might get sent somewhere else, or it might just get accessed here by a data warehouse in SQL. As I mentioned, I get asked all the time about selecting tools. So I actually came up with just a very simple way of comparing tools. So every client is different, and what we want to do is we want to just make a list of everything that matters to us, specifically reports or functionality, maybe how technical our team is, so how user-friendly the tool might be. We give it an importance, and then we rank them, out of 5. And the ranking can be done through research, and sometimes, if you hop on calls with sales reps, they can help you actually figure out the ranking here. And then at the end, what I like about this and what teams have enjoyed is that there's more of a fit score. So no tool is perfect for your stack, but there's typically one that will be a better fit. And that's actually what we're looking here. We're trying to understand what's the best option right now, but that option might change over time. And most companies are switching tools every 6 to 12 months, depending on what's coming out. Then we have the data schema. I think the data schema is maybe one of the most underrated parts of a data stack. We're talking specifically of mostly structured data here, but the data schema can be roughly be broken down into 4 general sections. We have events. These are the actions the user takes, like viewing a page, purchasing an order, uploading a photo. There's event properties that tell us more about that action. Then we have user properties, like name, email, city and region could be another one. And then there's special things. This could be like UTM tags, revenue is typically special, and the way it gets handled in a lot of tools. Maybe the ability to group users under organizations, like account-based marketing or something similar. User ID. But a lot of the structured data that you have will follow this logic in some way. Even something as simple as Google Analytics, which has a page view. The page view is the event. And then you have event properties about that page view, like the page name, the page URL, and so on. So when we come up with a data schema, this is roughly what we're looking to build. And we'll put it into something like this, a tracking plan, which can be Excel, can be Google Docs. I now see a lot of software tracking plan options. And we're just trying to map out all the different actions the user can take within our product and what are the different things we want to capture. So they sign up, we want to capture their name and their email and maybe how they authenticate it and whatever else they can do in our product. So we do this, we prioritize it, and then we implement it. Some of the things that are relevant for our conversation is naming convention. So you can see here in column H, where it says main goal for using Wistia, that's a camel case naming convention. So keeping your data consistent with a naming convention will be helpful. I was actually looking at a survey maybe about a week ago, and data scientists were asked where they spend most of the time. And I think about 60% of them said that the bulk of their time actually goes to just cleaning data, just making sense of it. And a lot of it comes down to how you structure it. So if you're capturing data from scratch or you're capturing new data, you should definitely have some logic to it. Otherwise, you'll have to spend way more time than trying to clean it and organize it and make it consistent. So this is what the data schema and a tracking plan is meant to solve. Then we have implementation and QA. For the most part, this is relatively straightforward. I think the biggest issues that come up here is just not having people to do it and not assigning ownership. I've been in companies where the engineering team is basically just given a plan and they need nothing about it, and they're just told implement it. So if you have basic conversations around who's going to handle it, it's relatively straightforward. I think the technical complexity of implementing data is not as high as other things. There's just some choices that your team will have to make. This backend versus client side question, libraries to use, how to maintain the accuracy of the data. Engineering teams can typically figure that out, but you need to have someone who's actually doing that work. And then lastly, on the little data process, it's just training best practices. So how do you make data available? The issue that I see here is there's a disconnect between what technical people think will happen. By technical, I mean engineers, data analysts, data scientists. They assume that people just take the data and use it, or they'll understand it as well as they do. But training is meant to solve that gap. And you can divide training into roughly 4 categories. You have group training sessions where you're going over the data, going over the tools you selected or you implemented. Then you have ad hoc or individual training. And you can focus on very specific things, very specific day-to-day questions. Then there's reactive. I find it really helpful when companies set up some kind of internal channel, maybe a channel on Slack or Teams or something else. And it's a place where people can post their questions or post their reports with concerns. And keep in mind, a lot of times here, the questions are not going to be very complex, but they're going to be important. A marketing person might say, I don't understand this report. The numbers don't make sense to me. Can someone explain it? And it's just a matter of figuring out what that report looks like and trying to explain the reasoning on how data is captured. But you need to have a way for people to ask those questions in an easy format. And then as best practices come up, be able to document that. And this can be done in Confluence or wikis or whatever else you might have, but just a place where someone can go and say, what data is available? Is there any dashboards that I should be looking at that are already pre-built and validated, things like that. So our process, strategy, stack design, data schema, implementation, and training. Something like this can typically be done quite well, I would say in about 60 to 90 days, with the biggest unknown being implementation time, trying to find time to implement things, regardless of the complexity. But 60 to 90 days is a good timeline here. And just to close the loop here on our initial case study on this mobile consumer app, we end up with something like Amplitude, for user behavior, having something like mobile attribution. This would be something like Branch, AppsFire. Then this is iterable for user communication and be able to send messages based on behavior. So, if a user does X, send this message. If they do Y, send another message. And be able to design workflows, which is becoming quite popular right now. And then, of course, be able to flow the data, the raw data that we were collecting into data warehouses. In their case, they were using Amazon Redshift and a few other things. And that data was going to be used for more advanced analysis, typically through SQL. So the stack was able to fulfill multiple requirements. It provided data to different teams, different stakeholders, while still also capturing the data for future use. So some final lessons learned here. The process that I showed you has a lot of research and upfront work before we ever write any code, before we ever implement any tools. That's by design. It reduces issues later on. And I would say most of the clients who come to me have typically already done some things, and now we have to go back and sort of fix them. And they're typically just missing some of that upfront work. They didn't think through all the different use cases. The data schema and how the data structure really ties everything together. The cleaner that is, the better that is, really the easier your life will be across the board. Of course, when we talk about data stacks, it's a lot of technical details, choosing tools, data schema, all that kind of stuff. But at the end of the day, you need to figure out who's going to be using this data, right? Who's the consumer here and what do they need? And they typically do not care about the technical details. They just need to know what this report means or what this KPI means. And of course, data preparation, it's a lot of work. That mobile consumer company I showed you had about 10 sources. And it's a lot of work to pull data from 10 sources. So anything you can do here to automate it as possible is quite beneficial. It reduces errors, manual labor, and it just adds more accuracy to your overall data stack. So we can move on to some Q&A. See if there's any questions, anything that you'd like me to go over or talk about in more detail.
Yeah. Thank you, Ruben, for this insightful presentation. And now, okay, so if you have any questions, you can type them in the Q&A window that is available on the screen. All right, so we have a few questions coming up. Let me read it one by one. Okay, so the first question that we have is, what is your view on ETL versus ELT, and what do you prefer to use for your clients?
Yeah, great question. So I talked about briefly about how that's changing. I would actually prefer the ELT model. I think with a lot of my clients, we actually want to capture as much as possible. So we extract it from lots of different sources, and we're gonna load it into typically a data warehouse like an Amazon Redshift or Postgres, and then we'll clean it or transform it and make it available for analysis. I think that's a little easier than maybe the older model. And again, the access of tools and computing power makes this quite straightforward.
All right. So the next question that we have is, how to efficiently do schema mapping for the data which is lying across multiple source systems without any data loss.
So how to map the data schema? Was that the question, sorry?
Yeah, basically how to effectively map the data and that too without having any data loss, or maybe minimizing the data loss.
Yeah, that's a good question. It really depends on, I would say it depends on two things. One is, of course, your data sources, what those data sources provide. Most tools are becoming much better at this. That is, you can expect the APIs to be quite reliable, quite modern, to not throttle how the data gets taken out. But I still see some use cases where that's not the case. And then the second question is on, once you take the data out, is what ability do you have to map that data? And I think it also ties somewhat to, to the data schema question that we talked about. If the data that went into those sources has a consistent naming convention, when it comes out, it will be already straightforward. But in a lot of cases, let's say if you're taking maybe like advertising data, like a Facebook ad data, you typically don't have a lot of control what data goes in. So you're limited to whatever Facebook might give you, and then you have to find a way to map it something else. In that case, it's really trying to find those identifiers that allow you to connect data, whether it's a user ID, maybe an anonymous ID like a cookie or something, and then mapping the data across that. Let me know if that answers your question.
Sure. All right. So the next question that we have is, so all-in-one tool approach versus specialized tool. What do you prefer and why?
I think the specialized tool approach is the way to go. And a lot of companies, are always confused when I tell them this, because they don't want to, most companies don't really want a stack of 5, 6, 10 tools. But it's really hard to find a tool that does it all, that does it all reliably. So we almost always end up specialized, whether it's on the marketing side, product side, or even just on the data stack side. We have very specialty things to manage data flows or data collection and things like that.
So we'll take one last question and we'll wrap up this Q&A session. So the next question that we have is, any tips on migrating from batch processing to streaming, and how to sort of switch between batch and streaming?
Yeah. I think a lot of the projects that I do are typically on the streaming front. What I've seen is of course, it depends on the tools that you're using. I find most of the modern tools that I'm seeing in stacks these days have a natural support for streaming. So the first question might be, do you have to upgrade your stack to be able to support this? I will say batch is not completely gone. I still see some batch processing, for example, in mobile, where the data has to be batched on the device and then gets sent, and it's not actually being streamed. It might get, it might just be a 5 or 10 minute delay, but there's still some batch in there. And then of course it becomes of what your infrastructure is able to handle. But if you were designing a stack from scratch today, and you were going with AWS, something similar, and maybe some of those open source tools that connect into AWS, I don't think this will be much of an issue. So the question becomes, what can you migrate really from your existing stack to add support for streaming?
Sure. All right. So thanks, Ruben, for all your answers to these questions. So moving on. So this was just the first webinar of this series. So we are coming up with our next webinar on simplifying change data capture, which is on 20th May, which is Thursday at 10:30 a.m. Eastern time. So you'll receive an email regarding this webinar. So you can register through the link provided in the email, or you can directly check the details on our website and register there. All right. So I would like to thank all the attendees for joining us today, and special thanks to Ruben for sharing the knowledge and experience with all of us. If you are interested in knowing more about Hevo or want to schedule a demo with our product expert, then please visit our website www.hevodata.com. You can also sign up for a free trial. If you have any questions or feedback about this webinar, then please write to me on Parag, PARAG@hevodata.com. See you for our next webinar. Till then, take care and stay safe.